This is the first one. Express the rate of the following reactions. So two equations are given. We need to write down the rate of reaction for these two equations separately. So how we will write for the first equation? Rate is equal to minus of dPCl5 upon dt, which is equal to dPCl3 upon dt, which is equal to dCl2 upon dt. Then how we will write for the second one? Rate is equal to minus of 1 by 2. Remember, whenever some specific number of coefficients are involved in the reaction, the rate of reaction with respect to that particular reactant or product need to be divided by its coefficient. So it becomes 1 by 2 of NO2 by dt, and which is equal to again 1 by 2 of dNO by dt, and which is equal to dO2 by dt. So that is the answer for this first problem. This is the second one. Given the reaction 2A gives rise to products, and in that process of reaction the concentration of A is decreasing from 0.5 mole per liter to 0.4 mole per liter in 10 minutes. Then you need to calculate the rate during this time interval. So how we will write the rate of reaction for this equation? Rate of reaction, this is equal to 1 by 2. I am not keeping negative sign. Whenever we are writing it theoretically, we can keep the negative and positive sign. But as we know that rate is always numerically positive, while working out numericals, don't keep the negative sign. So 1 by 2 dA by dt. And what is this dA? dA is nothing but the change in concentration of A in the specific time interval. And what is the time interval given? That is given as 10. So it becomes half of the change in concentration from 0.5 to 0.4. So 0.5 minus 0.4 divided by 10. So this is 1 by 2. This 1 by 2 becomes equal to 0.5, and this is 0.1, and this is another 1 by 10, that is 0.1. So this is equal to 0.005 mole liter inverse minute inverse. Now can you tell me what are the units for rate of reaction? As we are saying that rate is equal to change of concentration upon time. So what can be the units of rate of reaction? It is concentration upon time. Concentration we generally express in mole per liter, isn't it? Divided by time, and time can be expressed in terms of seconds, minutes, or even hours also. And here as it is given in minutes, it becomes minute inverse. So simply write it as time inverse. So units of rate of reaction are mole, liter inverse, time inverse. Is it clear? Let's move to the next problem. The decomposition of N2O5 in CCl4 solution at 318 Kelvin has been studied by monitoring the concentration of N2O5. Initially, the concentration of N2O5 is taken as 2.33 molar, and after 184 minutes, it is reduced to 2.08 molar. And this is a reaction taking place. 2N2O5 decomposes to give 4NO2 and O2. And what we need to calculate is the average rate of this reaction in terms of hours, minutes, as well as in seconds. So how we will write the rate for this reaction? Rate is equal to half of dN2O5 upon dt. So here it is half of what is the change in concentration of N2O5? It is from 2.33 to 2.08. And what is the time interval? The time interval is 184 minutes. So this one 1 by 2, 2.33 minus 2.05, this is equal to 0.25 upon 184. On solving this, you will get the value as 6.75 into 10 power minus 3 mole liter inverse minute inverse. So we got the answer for this one. So what we need to do in order to get the answer in terms of hours? So what we need to do here, these 184 minutes need to be converted into hours. So how we will convert? we can convert 184 minutes into hours by dividing with 60, and you'll be getting the value as 3.066 hours. So now the rate becomes rate equal to that half of 0.25 divided by 3.066, and on solving this we'll be getting the value as 4.07 into 10 power minus 2 mole liter inverse R inverse. And in order to express in terms of seconds, what we need to do? We need to convert this 184 minutes into seconds by multiplying with 60. So now the expression becomes rate is equal to half of, this is 0.25 divided by 184 into 60. And on solving this, you will be getting the answer as 1.13 into 10 power minus 5 mole liter inverse second inverse. So that is about the rate of this particular reaction in terms of N2O5. So this is the rate of reaction for this particular reaction in different units of time. This is the fourth problem. Ammonia and oxygen react at high temperature as given in the equation in order to form nitric oxide and water. And in a particular experiment, the rate of formation of NO is given as 3.6 is found to be 3.6 into 10 power minus 3 mole liter inverse second inverse. And we need to calculate the rate of disappearance of ammonia and rate of formation of water. So first we need to write the expression for rate of reaction. How we will write that? Rate is equal to minus of 1 by 4 dNH3 by dt, which is equal to minus of 1 by 5 dO2 by dt, which is equal to 1 by 4 dNO by dt, equal to 1 by 6 dH2O by dt. So even though rate is numerically always positive, it's always suggestible to write the negative sign in front of the reactants so that you will never do any mistake while solving theoretical questions. Anyhow, while working out the numerical, you will just leave this negative symbol. Then we need to calculate the disappearance of ammonia. See from this equation, rate of disappearance of ammonia and the rate of formation of NO both are the same, isn't it? So what will be the answer for rate of disappearance of ammonia? It will be definitely equal to rate of formation of NO, isn't it? And that value is directly given in the numerical, that is 3.6 into 10 power minus 3 mole liter inverse second inverse. For the second part, rate of formation of water is required. So rate of formation of water means dH2O by dt is required. So when this is required, you can equate with this one to get the final answer. dH2O by dt, that is what we require. This is equal to 6 upon 4 multiplied by dNO by dt. You know that rate of formation of NO is 3.6 into 10 power minus 3. So this becomes 0.9. So final answer is 5.4 into 10 power minus 3 mole liter inverse second inverse. So that is about the simple problems based on the rate of reaction.